It's the ERP Confab. I'm David Essex, industry editor at TechTarget's ERP website. AI-driven voice recognition is still a technical marvel and a tremendous convenience many of us take for granted, but it can also be used to record and analyze phone calls and texts. That sounds like an invasion of privacy, but in the right hands, speech-to-text can be a force for good, helping to keep credit cards secure and ensure legal compliance. My guest today is Nigel Cannings, CTO of Intelligent Voice, a UK-based maker of speech-to-text technology. He'll explain how this application of AI can catch criminals and protect privacy, and he'll detail the security risks, offer some possible solutions, as well as give his take on how generative AI changes the game. Nigel, thanks for joining the podcast. I'm wondering if you could start first by summarizing what Intelligent Voices technology does and what customers typically use it for.
Thanks very much for having me on today as well, David. Intelligent Voice, we specialize in speech and natural language processing technology at our core. Very much aimed at applications which have security implications, which have privacy implications. So very much thinking banks, insurance companies, legal, government, healthcare, really anyone who needs a large amount of audio or text data processed quickly and efficiently and doing it in a really secure way, even if that's in the cloud. So that's always been our ethos as a company.
I know that PCI, or payment card industry compliance, is one of the important uses of your technology. And I must confess, I didn't know a lot about it before I started reading about it at your website. For the listeners who might not be familiar with it, can you explain what PCI compliance is, why it's so important, and how your product helps to address it?
PCI is a kind of large selection of rules which surround the way people process credit card payments. And the bit that we're specifically looking at is how you process credit card payments on the phone. So, you call up and you order a bag of dog food or something or some insurance or whatever, and you read your credit card number over the phone. That's being recorded somewhere. So the idea is to eliminate all traces of your credit card number from any recording. So we use some pretty sophisticated algorithms which detect patterns. So, we know that credit card numbers are normally 16 digits or 13 digits long. They'll have an expiry date. They'll have a CVC code, that 3 or 4 digit code that comes with the card. And we look for those patterns and we delete them. And we use that a lot for anyone who's doing e-commerce or anything like that. We take the data in. We also provide them with a transcript for the rest of it as well, because they can use that for marketing and automation purposes. And then we eliminate all the credit card details, and that has to be done really accurately and really quickly, because you don't want to be hanging onto that data for any length of time. And we see that use case extending out further into more generally identifiable information. So a lot of the time people want to hang on to data, but they don't want sensitive stuff kept in the recording. So, you might attach an audio file to someone's database record, which has got their address and their name and so on in it, but you don't actually want the casual person coming along listening to the recording be able to get that. So we can eliminate names and addresses, social security numbers, things which could be used by a fraudster to impersonate you or to reuse your card details. Our job is to try and eliminate that from the recordings.
Can you sort of give a quick summary of some of the other ways that your underlying technology is used in business?
That's absolutely right. So the PCI rules specifically for credit cards is an industry level thing, and anyone who processes credit cards has to sign up for this code of practice effectively, and there's a lot of checks in terms of how that's done. But at a higher level, the storage of personal data is a really hot topic around the world. I know, obviously in Europe, we've seen GDPR as a big driver of that, but we're seeing this begin to kind of leach into US legislation as well in terms of how people store personal data, how long they store it for. California having taken the lead on it, but we're seeing kind of moves at a state and federal level to try and see a better protection of people's data. And voice data is in many ways one of the hardest to deal with, because it's not like, text data is easy, quote unquote. You can search for something and you find it really quickly. Voice data, we all speak differently. We even phrase things differently. I mean, if someone asks me my name, I'll probably say Nigel Cannings. If they ask me where I live, though, even the way I say my street address will be different to other people. The way I spell the numbers out. If I live at 315 Acacia Avenue, I might say 315 Acacia Avenue, or 315 or 315. Even something as simple as that is really quite difficult to pick out, whereas it would just be written as 315 in digits in text. So there's a lot of nuances to this, and historically the way we deal with that is by building rule sets out. And of course, we're now seeing in this new age of generative AI that we're all talking about, we're going to see some changes coming to that. But yeah, privacy is absolutely at the heart of this in terms of scrubbing a lot of this data from voice records. We've got, there's lots of different ways we can kind of touch businesses and consumers with this type of technology. So quality assurance is a really important one. So if you look in a contact center, for example, when you call into a contact center, the company want to make sure that you're happy. Fundamentally, if they want to make sure you're happy. So we have ways of looking at the sentiment of the customer. How was the customer when they started the call? How was the customer when they ended the call? We can look at the emotion that's in there, because sentiment and emotion don't always necessarily marry up. Does the person become angry? We can see how quickly the agent is talking to a customer, because that shows comprehension. If I speak too quickly, it's difficult for someone to understand me. We can look for things like vulnerability. This is a big thing we've been looking at recently. With an increasingly kind of aging population, what we're seeing is more and more issues with people being missold products. And we've seen this across the world, that you get people who are getting to the point where they're getting larger sums of money, perhaps through releasing equity from their house. They may get it from pension lump sums. They may get it through inheritance, and they're often being targeted even by legitimate companies to invest that money. Now, many of those people are not necessarily themselves in a fit state to make really complex decisions about those investments. So we have to detect whether or not the person who's receiving these calls, receiving this advice, genuinely understands what they're being asked.
Sounds like it could catch elder abuse, maybe.
Very much so. And this is something that certainly here in the UK, there's a very recent new rule come out from the Financial Conduct Authority, which places an onus on financial services companies to try and prevent that type of thing happening. So they have to be absolutely sure that if they're selling you something, that you fully understand, what it is, and also they can demonstrate the fact that you fully understand it. Because as people go, yeah, whatever, you want to invest, yeah,
Right.
You actually need to show that they're engaged. And unfortunately, we're never going to be in the position probably where we can tap into someone's home phone. I always think about, my own parents and my parents-in-law, they receive calls all the time. And unfortunately, and I really wish someone would have a service in place where we could actually intercept those calls, which are going to people who we know are vulnerable. And I get a text message saying, your father-in-law's on the phone to someone we think's a fraudster. Do something about it, or alert the bank. I mean, that would be quite a good thing. The technology exists for it, David. I mean, the technology is there to do that in real time. And it's something which mobile providers as well as fixed line providers could put in place if they wanted to. But it is actually incumbent upon them, because they're the only people who can, quote, intercept these calls. But I think it would be enormously valuable, with again with an increasingly aging population, with a higher incidence of vulnerability, dementia, and other similar issues that people begin to suffer from, that we should be able to protect people. So I'm very strongly in favour of those services, which, as I said, are technologically we can do it now. That we should actually really hope to see some of those things coming through.
Sounds like is it correct that a lot of your customers are companies that have call centers and are trying to exercise quality control and maybe training on the people who work in their call centers?
It's kind of a split, really. So we do have a lot of call center customers, but our historical base is actually on the trade floor. So this is the reason I started the company in the first place was, back in 2008, we all remember the world stopped. It literally stopped. And a lot of it was down to the antics of various traders in various banks who were doing things they shouldn't have done. And unfortunately, many of those were in London, not exclusively. But and we had the LIBOR scandal and all of this type of stuff. And I had this, in a sense, quite naive idea that, we could listen into the phone calls which we knew were problematic, and the emails and we had email was Enron. By the time we got to 2008, people were actually using the phone to do things because they knew people were reading emails. And I thought we could listen into this stuff. And so I developed a product which could actually listen into phone calls, read emails, look at chat messages, and start to divine patterns of bad behavior. And so our customers are big banks. I mean, we have a lot of kind of household names who don't like us talking about who they are because they don't like their staff necessarily understanding the level of capability that we've got to monitor them. But yeah, so if you're working for a large bank and you're on the phone trading, there's a reasonably good chance that our software is sitting there listening to what you're saying. If you're on a Teams meeting there, the same thing. And we do more than transcription. We do understanding. We do what's called biometric identification, where you identify someone by the sound of their voice, because there's a real issue with metadata in these places. How do you correlate the person who's on the phone with the metadata you've got? So historically financial institutions, and then over the years we've moved towards the contact center. But, we're now seeing, interestingly, a very big shift into a much wider field away from just voice. As I come from a text and voice world, with the advent of kind of the newer forms of large language model, that people are really interested to see what can be done with all communications in their business rather than just, say, the voice communications.
I noticed that you were previously an attorney. Why did you leave that profession to go into software?
Oh, well, there you go. So you should really ask me why did I become an attorney is actually the bigger question, you see. So I'd always wanted to be a technologist. I have to be honest. I was really lucky that my dad sold the first ever personal computers in Europe. So this is 1978. And he'd actually gone over to California and gone to all these kind of people had these garages around the place, which are, bits of stuff in, and he kind of brought a load of these back. And so he sold the first Commodore PET, the first Apple II. I think he sold the first ever Apple computer in Europe through this small shop he had in East London. And so I'd been around computers from very young. I was kind of 10 years old when all this was going on. And I moved to the States for a year when I was 18. I did a year of school out here and then came back home. And I said to him, I want to do what you do. I want to be a businessman. And he was very rude to me. I shan't say what he said, but he did swear at me for the first time in his life and told me to go and get a proper job instead. And suggested that should I ever decide that I wanted to do what he did, I should come back and speak to him after I'd, made a bit of money. So I couldn't add up. I couldn't stand the sight of blood. They were very, I was left with limited options at that point. So I became an attorney. But I came back. I worked for software companies most of my life, and ended up. I made some money out of stock options in the kind of 99 2000 era, And I was lucky enough to have a bit of money in my pocket, walked back into his office, said, guess what, I'm ready. And he said, what are you talking about? I said, no. Do you remember that conversation we had like 17 years ago? No. And so at that point, I started my own business and I decided I was going to do that technology thing. So yeah, I loved being an attorney. I really enjoyed it. For me, a lot of it was about, the words and that type of stuff. And that's really what led me into doing the type of technology I do today. I started the first software company I started specialized in natural language processing technology. I have the very dubious honor of being the first person to write a trending tool for Twitter, which I did even before Twitter did. I knew a guy who worked there who gave me access to all the tweets through their what was then the instant messaging feed for all the messages, and wrote a trending tool. So that's how I became a technologist, and so I have to airbrush my guilty past now and pretend I've been a technologist my whole life, but no, it's not true, sadly.
So I imagine, though, that maybe your legal background helped you in some way in your work at Intelligent Voice. Is that true?
Very much so, yeah. I mean, and in a number of different ways as well. And one of the biggest ones actually is my kind of fanatical devotion to security and privacy. We've architected the system from day one to be private and secure. And that meant that we started very much working in the on-premise world. So if you look at a lot of speech and NLP companies, they actually start in the cloud. So if you want, say, take this podcast, for example, if you want to have this transcribed, the chances are you would send it to a cloud provider. And that could be, Google, it could be Otter, it could be Amazon, it could be all of these people. I work the other way around because my concern was always that audio in particular was so sensitive and, contains so much information that we should secure this stuff from day one. So I suppose, that confidentiality and privilege and so on that came from privilege, as in legal privilege, coming from the legal world was really very much what made me think that. And then the second side of it is it also meant that I said I would never sell to lawyers as well. I, absolutely swore I would never sell to lawyers, which many of my legal clients will now find highly amusing as we have a lot of them. But yeah, and again, it also gave me a deep understanding of language, and that's allowed me to translate that into kind of highly sophisticated technology solutions for people who've got big language problems that they need to solve.
So I think most people have become familiar with just the tremendous conveniences provided by speech recognition and natural language processing. But there are some drawbacks and potential misuses. Which are the ones that worry you the most?
I mean, I touched briefly a second ago on the security issues, which to me is still one of the biggest problems that we have. Speech technology inherently is insecure. Telephony technology is inherently insecure. I mean, most telephone calls that take place over the internet are not encrypted, and very few people know that. In fact, if we introduced a telephone call into a Zoom call, then that changes the whole encryption pattern because actually the telephony piece is no longer encrypted. So we've already got big problems there. But actually, cost is another one as well. One of the things that I think people don't realize is the sheer processing power involved in doing speech recognition. And, if you're doing speech recognition on your phone, a lot of that stuff is being sent out to the cloud still. That incurs data charges. That means that the price of your phone goes up because effectively it's having to subsidize the voice assistant. When you buy your little Amazon device that sits in the home, I have to be very careful not to say its name out loud because it will start talking back to me. But the little thing that's sitting very close to me at the moment, that costs a lot of money to run. I mean, billions we're talking. This stuff is not cheap. So privacy is a real thing. And actually talking about the little round disky thing that Amazon produce, again, privacy is a real concern with this stuff because what we know is that because it's difficult, because speech processing is difficult, needs a lot of training to get it right, people have taken shortcuts in terms of how they get that training done. So, for example, Amazon sent a whole load of people's voice recordings out to Eastern Europe to be listened into and transcribed. Now, strictly speaking, it's in the terms of service. Yeah. But actually, how many people know that they're accidentally activating it, maybe 12, 15, 20 times a day, and those activations are being sent off for a human being to listen to elsewhere in the world.
Bias in AI has been getting a lot of attention in the past couple of years, and it's, prompting governments to get really serious about seeking regulatory solutions to that. What's your general take on the bias issue, and do you think there are some technical answers that are particularly promising?
We've kind of already shot ourselves in both feet as far as this is concerned. So, I mean, and in many ways, we're trying to answer a question now which is almost impossible to answer given where we've got to. The technology has moved on so fast and so far and is in so many people's hands that actually to uninvent a lot of the problems that we've got is going to be very, very difficult. And I don't think that regulation is going to save us. I mean, I love what the EU has been trying to do in certain high risk areas around kind of use of kind of profiling and biometrics with AI. I think it's really important to kind of make sure the state is not using AI against us. But actually, in terms of where we've already got to with things like large language models, I think it's already gone too far. If you take any large language model which is out there at the moment, I mean, bear in mind that anyone can download a large language model from Meta. You take the Llama 2 model and generate highly sophisticated chatbots with it. I mean, literally anyone can do it. And actually, you can do it virtually for free now. That bias is baked in there and is never coming out. And it's not in Meta's interest. And actually, one of the really interesting things that I think is happening is we're talking about moving to a world where we have less bias. And I think it's really important that in the deployment of these systems, as much as anything, we make sure we do introduce guardrails and rules. So, we do a lot of work with large language modeling, and our approach is to box the large language model in terms of its potential responses to make sure that what we produce for our customer goes through a multi-level filter so that by the time the answer comes out, it's super structured. So we don't just say, generate an answer. We're saying, the answer that you generate must follow this format. It must say this type of thing. It mustn't say this type of thing. It's really, really prescriptive in terms of what it can do. But that kind of falls to us as the producer of the solution. In terms of building the thing in the first place, what we're seeing is a lot of the people that you would consider to be useful in kind of debiasing things are actually stepping away from it. So just take here in the UK, for example. Like it or not, I think most people still see the BBC as a reasonably impartial arbiter of news and content globally. It's still, yes, there are people who don't trust it, but actually most people would say the BBC has got a pretty good take on it. And so you would think that actually we'd want to be using the type of content that the BBC has to produce unbiased large language models. If you think you train something on BBC News, the chances are it's actually going to be pretty unbiased in terms of its approach to life. Well, the BBC have blocked any attempts to do that. They are refusing to allow that content to be used. The same with the New York Times, CNN, Reuters, Medium, the blogging site have just announced that they're blocking it. Hundreds of other sites are blocking access to companies who want to take that data and use it to train statistical language models. But there's a whole bunch of people who aren't, and the bunch of people who aren't are generally the people who are slightly more on the fringes. So what we're actually doing is we're encouraging people to train models, quote, legally on more toxic content, on less unbiased content than actually was previously the case. I have a lot of concerns about the approach that companies are taking. They're saying, well, we're going to monetize this. But actually, who the hell is going to pay the New York Times for the content? Who's going to pay the BBC? Here in the UK, we have to pay every year to own a television. That money goes to the BBC. I've paid for that stuff. I'd like to get it, please, if you don't mind. and we are not at the point yet where we understand enough about the technology that we've built to effectively debias it. There is not a single guardrail that I've seen that I haven't seen someone get round so far. And that, and I think that's the problem. It's always a cat and mouse game with these things. So I am not, personally, I've not seen a lot of great approaches to debiasing things, and I'm really concerned about the direction of travel in terms of the availability of high quality, unbiased training data, particularly for smaller companies who couldn't afford to pay the BBC or the New York Times for their content, and will be scraping stuff from the dredgier parts of the internet, because that's the content that you have to train this stuff.
So your approach at Intelligent Voice, though, has been, I think you said, to box things in a bit. You're trying to put some structure around it to kind of get a control over this.
You see, there's two ways you can look at kind of modern AI systems or modern generative AI. So, we're talking a lot at the moment about generative AI, but actually the concept of a language model per se has been around for 50 years. So, because language models are just predictors, all they're really designed to do at heart is to take some input and predict the next output. And we've been using these in speech recognition since the 80s, because, you might take the phrase, the cat sat on the mat, right? Nice, easy phrase. If my speech recognition algorithm may not be super perfect, and for many years, we struggled sometimes to differentiate between words. So if the system thought the cat sat on and then it had a choice of two words, rat or mat, our language model would say it must be mat. So this idea of statistical language modeling has been around for a really long time. All that changed was in kind of 2017, 2018, with the advent of what are called transformer models, we could train statistical language models in a much looser fashion than we used to be able to, with a lot more data. Because at that point, every word could be linked to every other word in a much longer sequence than previously available. And we've been increasing that window of content that we can put in and generate all the time, and we're now seeing models that will accept 100,000 words or 100,000 tokens of input. It's really changed significantly over even a very short period of time. We don't really understand how this stuff works even today. So what you have to do is look at the predictive side of language models rather than the generative side of language models. What's changed is we've managed to make these things not just predict things, we've also managed to make them generate things. So we generate images, we can generate poetry, we can generate articles. We can, in a few years' time, I hate to say this, we'll be able to generate podcasts. The pair of us will be, there will just be a picture and a voice sample, and it'll be generate a podcast about this, and off it will go. So what we focus on is the predictive side. So we understand how to make a large language model give predictable output, as opposed to the generative side, which produces these hallucinations that we hear a lot about, where it just kind of starts, because you've asked it a question, it feels it has to answer. That's the thing about large language model. It doesn't say, I'm really sorry, I don't know. If you go to Google and you Google something, if Google doesn't know, Google will not make an answer up. Google will say no results. A large language model will not do that. It will produce a result whatever happens. And people don't seem to understand this. In fact, there's a really interesting paper I read recently where a university went out and they set people a series of tasks, and they said, we use ChatGPT and Google for it. Here are the two things we want you to use. And then they asked afterwards how much people trusted the results they got back. And people trusted the output from ChatGPT twice as much as the output from Google. And yet, Google got everything factually correct, and half of what ChatGPT said was absolute nonsense. And so it's really interesting how this Gen AI stuff is engendering a false sense of security.
I think it would be important for the listeners to get your take on how you think generative AI is going to be applied and maybe should be applied going forward versus the other kind, the machine learning predictive kind that isn't trying to make things up, isn't trying to create something new. Do you see how this is maybe going to shake out or divide onto two different paths perhaps going forward?
Well, I think, there's always going to be a place for kind of what you might call standard machine learning in a sense, which is, very statistics based. But the line is blurring, definitely, because what we're seeing is that people are going to be using generative AI to produce things which are more structured. So, I think the way most people have been playing around with things like ChatGPT is, write me an essay on the fall of Rome, and there's a whole load of kids are turning up at school with this, here's the essay I produced, honest, it was me. Or they're beginning to say, people are thinking more, well, summarize this, write me a list of action points. But one of the really interesting areas that we're seeing develop is effectively generating kind of pseudocode or things which are more structured from the unstructured. And I'll give you a couple of examples of that. So one of which is in search. And I think one of the big revolutionary areas for Gen AI is going to be in the search domain, because what it will allow us to do is to use quite sophisticated natural language queries, asking questions about data, which can be translated onto any schema. So it's not just about, can I query Google, but, can I query my SAP system? Can I look at the underlying database structure and really drill down, even in sophisticated ways that the people who actually generate the software haven't thought of. So we'll see people saying, here's a database schema. Right, there you go. I'm going to ask a series of questions. You produce a query, which will then go off and query that database, will return data to me. I will then ask you a further series of questions about the data that you've returned, and you'll go off and you might perform a different task. This time you may not query the database. You might go and look at a different enterprise data store to answer that question. So we're going to see the kind of the power of information put at people's fingertips. And I don't think many people have really thought about the power that they're going to get from interacting with what are currently legacy or difficult to deal with systems. So that generation of code, should we call it, from speech. But the other one is also the extractive element of it. So we're working on a number of projects at the moment where we are using large language models to help us extract structured data from unstructured data. Now, we spoke before about PCI and PII. That's a pretty straightforward one. Here's a transcript, remove all names. Great, done. Large language model can do that pretty easily. Remove credit card information. Yeah, not so easy, but you give it a few examples of what credit card information looks like, you might be able to get there. But when you get down to things like, here is a long conversation between a caller and an agent. I need to know why that person called. I need to know how happy they were and what's the chances of that person ever ringing back again. We're actually beginning to put some of that into the hands of consumers. I say consumers, users, through large language modeling. So I think the kind of the dark arts of data analysis, let me put it that way, are things which actually will use generative AI as the interface between ordinary users and very, very detailed and sophisticated data. And for me, that's one of the most exciting things. And that is a purely generative capability. That's something that we've never been able to do before.
Earlier, you used the phrase legacy, and one of the better known legacy systems is ERP and related things like the HR component of it. And you can include CRM in there and a number of other business applications. So pretty much all the ERP vendors are trying to jump on the generative AI bandwagon. And really seem to be focusing on changing the user experience quite a bit and allowing a lot more voice control, but also just text recognition and kind of creating a more user-friendly interface to the business processes, but also some of that underlying business data that the ERP system is holding. How do you see that playing out, the application of speech recognition in the ERP world? What do you think is the limit in terms of how much voice-based technologies can replace keyboards, mice, screens, and the other ways, the other input and output devices?
It is an interesting question because I, for example, do not use voice as an input medium. So here am I. I'm a man who's run a speech recognition company for the last 13 or so years. I don't use voice as an input medium because I don't like it. I find it very counterintuitive. I don't like it. From time to time, I will use it for short input stuff. If I'm walking along, one of the problems is as humans, we expect things to be 100% perfect. 95% perfect is no good. If I'm walking on the road and trying to send a WhatsApp to my wife saying I'll be on the 6 o'clock train and it says that transcribes as 7 o'clock train, that's no good to me. And it means I've got to stop. Mm-hmm. I've got to get my fat finger out and try and change the 7 to a 6. And I might as well have typed it in the first place. So we're really unforgiving of these types of interface, of the really direct medium. So I think that, for limited voice control, speech is fantastic. So, Amazon devices, so you've got to be really careful in case it goes off. Amazon device, switch my lights off, is great. And Amazon ran a survey of how people interact with their voice assistant, and almost all use cases are, what's the news, what's the weather, turn my lights off. And that's pretty much it. This is something which had billions of dollars spent on it. So we're not using voice in a sophisticated manner at the front end. Where I think voice and video particularly are going to be used more extensively is in the back end. So the ability to have a natural conversation in a number of different ways. So let's say I want to call my call center up, and it doesn't matter what the call center does. Call center could be somewhere that I change my password. It could be somewhere where I need employment advice, or I just need to talk to an HR advisor. I mean, this goes across absolutely all elements. It's an internal help desk. Doesn't matter what it is, but I need two things to happen. Each side of that has an outcome that they need. So I, as the person calling in, want my problem resolved as quickly as possible. On the other side of it, the agent wants to understand that problem as quickly as possible, give the best possible solution, and look like a hero in front of their boss. That's basically what it comes down to. So we can now use a combination of voice technology and generative AI technology to start to achieve that. Because I call up and I explain what my problem is. The agent's listening, but so is the speech technology, and so is the large language model. And it's actually searching through the knowledge base at that point to put something in front of the agent saying, I found this for you. You didn't have to ask me to. I found it for you. Pick a potential solution. And it means that we can put a lot more knowledge in the hands of the person in the contact center. But then it goes deeper than that, because then we start to eliminate the human, because I'd actually like to speak to a human, but I don't necessarily need to speak to a human. And one of the things we're seeing at the moment is the potential pass off from human to computer. So here's a really scary thought. You call up someone in your bank, and when you call up, the bank have no idea why you're calling. It could be you want a simple balance inquiry. It could be a very sophisticated international transfer of funds, right? Doesn't matter what it is. But once you've started talking to the agent, if it becomes clear that it's something which is routine, you could be handed off to a voice bot which sounds exactly like the agent you were just talking to. So you will not know that you've been passed seamlessly from one to the other. If it's a complex query that requires expertise, then you'll be left with the human agent, but the human agent may have some assistance on screen in front of them which helps them deal with that problem. So you get the human-like experience, because if it's just a balance inquiry, then you don't need a human to read that out. You can have the machine read it out sounding like the human you spoke to. So this is where we're going to see a really sophisticated blend of kind of computer and human agents sitting behind a lot of the interactions that we have, and that cuts across a whole load of things in the ERP world in terms of the type, underlying databases that we're going to be connecting to and updating. So it's I think it's really exciting and a tiny bit scary as well.
Yeah. I suppose it's important for me and others to maintain the distinction between voice input or output and just typed text, which is now being handled more effectively, it seems, with generative AI. So it isn't just what people are speaking, it's that, but also words that are being typed, but maybe better understood now by the AI.
Yeah, it's a multimodal thing. And actually, when we're dealing with voice, we're doing two things. We are looking at it from a vocalic thing. So how do I sound? What's my tone of voice? Am I sounding upset? But also a lot of what we're doing is just analyzing the text. So what you're doing is you're taking a text transcript and then you're putting that together with the other text that is coming in, and the large language model doesn't care. It's just all text to the large language model. And in fact, multimodal can extend further. We can look at video and see, where are my eyes looking? I mean, I've seen this used in a number of meeting applications. You've got 40 people on a conference call. You detect the person whose head is drifting forward towards the desk. So, we're beginning to use video analysis in this as well. So very sophisticated across multiple different modalities.
Can you give us an idea of what the next thing or two is coming from your company?
Oh, definitely. Yeah. So there's a couple of very interesting things we're working on. So one is completely confidential processing. So one of the things at the moment is we all love the cloud, right? I love the cloud. Everyone loves the cloud. But if you send data to the cloud for processing, at some point that data sits in an unencrypted form. So during transmission, it's encrypted. When it's at rest, it's encrypted. But when it's being processed, it's unencrypted. So that means that any data that you send to a cloud provider is potentially subject to surveillance. It's potentially subject to misuse. It doesn't have to be voice data, it can be text data, database stuff, anything is out there. And that could be government interference, that could be international government interference, that could be bad actors within the company that you're working with. Doesn't matter, it happens. So what we've developed is a way of processing that data completely encrypted. So effectively, you'll be able to send your data to the cloud, say your podcast, and you want it transcribed. It gets sent to the cloud vendor can never hear it, nor can they read the results of the processor. And that's sent back to you in an encrypted form and is received by you in an encrypted way. We're thinking, healthcare. We're thinking, financial data. For anyone's data, why should a cloud provider be able to listen into my calls, read my emails? So that's a really exciting one, and we've just got our first patent on that particular process, and we're going into development on it pretty much straight away. So that's one of the big things that we're working on. But also biologically inspired neural networks. So this is my particular favorite. There's one guy who works for me who is an expert in creating networks which operate like real human organs. So like in this case, the ear, would you believe? So the human ear is actually a neural network, and it's a biological neural network, and it's just the way we get information to the brain uses a neural network. So we're looking at how do we take the power of these large language models, but actually reduce their complexity massively, so that actually you'll be able to run a large language model on your iPhone. Because at the moment, I need a supercomputer to run it on. Why should I not be able to run it locally? So that's a slightly longer term project, but we've got people working on it right now.
This has been a wonderful conversation, and I appreciate your time today.
Thank you for having me on.